Beneath the blistering heat of northern Ghana, a silent hydrological battle has played out for centuries. When standard shallow water sources vanish entirely, rural communities turn to a remarkable, ancient subterranean architecture. For generations, surface ponds and standard shallow pits have offered a fragile lifeline, prone to rapid contamination. Evaporation rates in the dry season strip these ponds bare, leaving communities staring down severe dehydration crises. The geography itself presents a paradox. Northern Ghana sits atop complex, stubborn, hard-to-tap hydrogeological formations. Hard, crystalline basement rocks block conventional modern drilling efforts, frustrating engineers for decades. Yet, long before industrial heavy machinery arrived, local ancestors discovered a masterclass in localized hydrology. Enter the Mole Hole Well, an ingenious hyper-narrow shaft designed to bypass evaporation and rock barriers alike. These shafts are carved just wide enough for a single person to descend, minimizing surface exposure to the blazing sun. By tunneling downward at precise angles, builders tap into localized perched aquifers trapped within weathered zones. The physics are remarkably efficient. Minimal surface area means drastically reduced water loss through vaporization. They act as natural cool storage containers, keeping vital drinking water potable even at the height of the dry season. Centuries of empirical geological knowledge passed down orally enabled communities to read subtle surface flora clues. Specific trees and deep-rooted shrubs indicate exactly where moisture accumulates underground beneath the scorching sand. This ancient infrastructure continues to defy modern abandonment, serving as an enduring testament to survival engineering. Reaching the water table is only half the battle. Maintaining water purity inside a narrow subterranean shaft requires strict discipline. Because the surface opening is so small, accidental contamination from surface debris and livestock is largely prevented. Traditional covers woven from local grasses seal the aperture tightly when the well is not actively in use. Extraction requires specialized tools, often a slender calabash gourd or animal skin bucket attached to a sturdy fiber rope. This narrow vessel design ensures that only individual portions are drawn, preventing large agitators from muddying the source. Community governance plays an equally crucial role in preserving these vital water veins through prolonged dry seasons. Elder councils enforce strict rationing schedules, ensuring equitable access for families and livestock alike. When wet seasons return, sediment that has settled at the bottom is carefully cleared out during communal maintenance rituals. This annual dredging resets the well capacity, preparing the underground reservoir for the next cycle of scorching heat. Geologists studying these indigenous systems note that they often outperform poorly maintained modern boreholes. While imported diesel pumps frequently break down due to lack of spare parts, mole holes rely entirely on human scale. There are no motors to burn out, no electronic panels to fail, and no expensive imported gaskets required. The knowledge required to site, dig, and maintain these wells is preserved through oral traditions and hands-on apprenticeships. As climate volatility increases arid pressures across the Sahel, engineers are revisiting these ancient indigenous methods. The mole hole wells of northern Ghana stand as a profound reminder that sustainable survival often depends on ancient wisdom. Beyond physical shoring, ancient well builders mastered the delicate art of thermal regulation inside the shaft. Deep earthen walls insulate the subterranean reservoir from scorching daytime temperatures on the savanna surface. This natural temperature gradient prevents rapid bacterial proliferation that plagues exposed surface water pools. Air circulation shafts were occasionally carved alongside the main bore to maintain oxygen levels for descending diggers. Every measurement was calculated using body proportions and generational metrics passed down through oral masterclasses. Master hydrogeologists could smell subterranean moisture shifts by testing the humidity of night air over specific soils. When seasonal rains finally break the drought, these underground networks absorb recharge waters without destructive flooding. Permeable earth layers act as giant natural sponges, slowing down rushing torrents into steady percolation. This prevents the catastrophic soil erosion that often ruins modern, poorly planned civil engineering projects. Communities organized around these wells developed strict codes of conduct to protect the shared water basin. Wasting a single drop was treated as a communal offense, ensuring absolute conservation during peak dry months. Modern development planners often overlook these localized systems, favoring high-cost mechanical boreholes instead. Yet when imported fuel runs dry and replacement parts fail to arrive, The mole-hole wells remain operational. They stand as a testament to the fact that true sustainability relies on harmony with local ecological limits. The engineering genius embedded in these earthen shafts continues to whisper ancient survival secrets to the modern world. Maintaining these vital subsurface arteries requires constant vigilance and specialized communal labor. When the seasonal rains finally arrive, they bring not just life, but the constant threat of siltation and structural collapse. Teams of skilled diggers descend into the narrow shafts to inspect and reinforce the porous earthen walls. They utilize interlaced branches and natural clay linings to shore up loose, sandy overburden without chemical binders. This organic armature allows lateral groundwater seepage while successfully blocking abrasive debris from choking the well eye. Without modern PVC casings or industrial filters, the system relies entirely on the balanced physics of natural percolation. The economic implications are profound, freeing impoverished rural households from the crippling costs of imported pumps. Every repaired shaft represents a victory of decentralized technology over centralized infrastructure failures. As climate volatility deepens across the Sahel, international hydrologists are finally taking notice of these ancient methods. Universities and NGOs now document mole-hole architecture to integrate indigenous wisdom into future drought relief blueprints. Yet the true guardians of this knowledge remain the village elders and generational diggers of northern Ghana. Their hands-on apprenticeships ensure that the secrets of the mole-hole will outlive any temporary modern intervention. In an era dominated by high-tech fixes and failing infrastructure, these simple earthen shafts offer a humbling lesson. True sustainability is not about conquering nature with brute force, but listening closely to what the earth provides. And so, beneath the burning sands of northern Ghana, the ancient mole-hole wells continue to flow, unbroken and alive. Looking forward, international climate researchers are examining how indigenous mole-hole design can inform modern drought resilience. As rainfall patterns become increasingly erratic across the Sahel, decentralized water harvesting is taking center stage. Expensive centralized pumping grids often fail when maintenance budgets dry up or imported fuel becomes scarce. In stark contrast, mole-hole wells remain entirely within the technological control of the communities they serve. Engineers are now integrating low-impact subterranean catchment theories into rural development blueprints across West Africa. Whenever drought threatens modern settlements, the silent, damp chambers of these ancient wells offer a timeless answer. As long as the sun bakes the plains of northern Ghana, the mole-hole wells will stand as monuments to human endurance. As we trace the full arc of northern Ghana's water heritage, the true brilliance of the mole-hole well comes into sharp focus. These subterranean shafts are not merely relics of the past, they are active monuments to human resilience and ingenuity. By bypassing evaporation, protecting delicate aquifers, and enforcing strict community stewardship, communities mastered survival. The invisible biofilters of charcoal and sand prove that low-tech solutions can often outperform expensive imported machinery. International hydrologists now recognize that the future of drought resilience lies in respecting these ancient Earth systems. When modern pumps rust and centralized grids fail, the quiet, damp chambers of the mole-holes continue to provide. Oral traditions and hands-on apprenticeships ensure this vital survival knowledge passes safely to the next generation. Schools and community workshops in the region are embedding indigenous water science directly into local education. This guarantees that the engineering secrets of northern Ghana's ancestors will never be lost to time. True innovation is not always about inventing something new, but about listening to what the earth has taught us. Across the vast arid plains of the Sahel, these humble shafts stand as timeless proof that humanity and nature can coexist. And as long as the sun beats down on northern Ghana, the ancient mole-hole wells will continue to flow. When modern mechanized pumps break down in remote West African communities, the true value of indigenous engineering becomes starkly apparent. Imported diesel engines and high-maintenance solar arrays frequently fail when replacement parts or technical specialists are miles away. In contrast, the mole-hole wells rely entirely on human scale, local materials, and generational community oversight. Forward-thinking hydrogeologists are now integrating these ancient siting principles into official regional water development blueprints. By merging empirical indigenous knowledge with modern ecological monitoring, planners can construct truly resilient supply networks. The engineering genius of northern Ghana's ancient wells offers a profound lesson for a world facing worsening climate extremes. True sustainability is not about conquering nature with heavy machinery, but listening closely to the limits of the earth. These low-tech, subterranean shafts prove that localized solutions frequently outlast complex imported infrastructure. As long as the sun bakes the savanna, the mole-hole wells of northern Ghana will remain monuments to human ingenuity. Quietly, perfectly, and resiliently, they continue to draw life from the desert.